Guys, it's day 96 of the 100 Days of LeetCode. We got a medium problem, count good meals. Let's do it. So a good meal is a meal that contains exactly two different food items with a sum of deliciousness equal to a power of 2. Now, you can pick any two different foods to make a good meal. Given an array of integers deliciousness, where the ith value is the deliciousness of the ith item of food, return the number of different good meals you can make from this list modulo 10 to the 9 plus 7. Note that items with different indices are considered different even if they have the same deliciousness value. That's going to come in handy because here we have 3 different ones and we can make several different good meals with those 3 ones, right? So example 1, we have 1, 3, 5, 7, and 9. We output 4 because we can make 1, 3, 1, 7, 3, 5, and 7, 9. Now, example 2, we have this array, and the answer is 15 because you can make 1, 1, 3 different ways. You can make 1, 3, 9 different ways, and 1, 7, 3 ways, right? And that's because we have all those different 1s and all those different 3s, right? You can check it. 1 plus 1 equals 2, which is of course a power of 2. This equals 4. This equals 8, and those are all powers of 2. One thing we want to note as well is that we can have up to 2 to the 20 as one of our values. This is going to be important because with this, we know that the maximum good meal that we could have would be equal to 2 to the 21. Because 2 to the 20 plus 2 to the 20 is equal to 2 to the 21, and we're going to use that in our solution. Okay, so let's write the code. The first thing I'm going to do, I'm going to create num meals. It's going to be 0. This is going to be the number of delicious meals. And, you know, here we're going to do some stuff. And then at the bottom, of course, we want to return this. What did they say? Modulo 10 to the 9 plus 7, right? That's how we're returning it. Okay, so now it's time to actually do the stuff that I said we were going to do. So the first thing we're going to do is we're going to create a dictionary or a hash table. In Python, it's a dictionary. And we're going to populate it. So to populate that, we can just iterate through our deliciousness list, and we can just say meals of I. So with I is the key, we can say meals.get I or 0 plus 1. Now what this does, it basically says, okay, if there's a value already with the key I, we're just going to add 1 to it. If not, we're going to give it the default value of 0, add 1 to that, and we'll be at 1. Okay, so now we have the meals list populated, or the meals dictionary populated, excuse me, and we can actually work with it. So what we're going to do is we're going to use a nested loop, but the first one is going to be, we can do for I in meals now, right? So we're going to iterate through the keys of our meals dictionary, and then we can say for j in range 22. The reason why I'm doing 22 is because this is basically going to represent iterating through all our potential powers of 2. And I already went over the fact that we can have up to 2 to the 21 as one of our good meals, right? So we want to iterate through range 22 because, of course, this is exclusive. So we'll actually iterate all the way to 21 and then stop, right? So that's why we're doing range to the 22. Now in here, what we're going to do is we're going to say difference, right, or diff, is equal to 2 raised to the j minus I. Now we're going to essentially look for this difference value in our dictionary. Now we already have our I. Wherever we at, we already know one of the values of our potential good meal, and the other one is going to be essentially any one of the differences of any power of 2 minus I. So that's why we're creating this I, and now we can actually look for it and look for it in the hash table and then update it if need be. So the first thing we're going to say is we need two different cases. We need to check if diff is equal to I, because if it is, well, that's going to be different than a case where diff is not equal to I, right? So if diff is equal to I, what we're going to do is we're just going to increment num meals, basically the amount of combinations that could come from that many times that I is in the actual deliciousness array. And that's stored, of course, in our meals dictionary. So the way to compute number of combinations is like this. We're going to say meals I, plus, times meals I minus 1 integer divided by 2. Now, you can do the math if you want, but basically, if there's 3 different instances of this, then there should be 3 combinations, right? 1, 2, the first one, the third one, and then the second one, and the fourth one, and that's actually 4 combinations. So this formula will basically give us however many combinations there are of those 2 meals with the same deliciousness value that we can actually make. And then we're just going to increment number of meals by whatever this gives us, okay? Now that's only if difference is equal to I. Of course, if difference is not equal to I, well, we have to do something sort of similar, but we have to avoid the situation of double counting. And the way we avoid the double counting is we're only going to check when diff is greater than or equal to I. Now, what this does is it essentially says, okay, if our difference is greater than or equal to our meal, we're going to count it. But if not, we don't count it. And the reason why we don't count it is because there will be a point where the difference will be less than I, and that will be like an instance where we're double counting. So we don't want to count that. So we're going to basically filter out all the doubles just by doing this. And what I mean by double counting is if you take, say, for example, the 7 at the 3rd index, this 9th at the 4th index, you don't want to count it twice, because in one pass through the hash map you get 7 and 9, and in the second one you get 9 and 7. You don't want to do that. So that is why we're using this diff greater than or equal to I to sort of filter that out. And if we're in here, what we want to do is we want to increment our number of meals by just the product of how many times these 2 numbers appear, right? Because if we had, for example, like here, 3 3s and 3 1s, right? Well, we want to, there's actually going to be 9 different ways to combine those 3. So we can just say, 3 times 3, right? So basically the amount of times that this is in our meals dictionary, and then the amount of times that this is in our meals dictionary, I only meant to do the 3s, that's how much we're going to be incrementing our number of meals. So this we can just do plus equal meals I times meals diff. Okay, and then we can just return, of course, num meals modulo that. Let's submit our code. Let's see. Key error 15. Yeah, because I also need to check whether or not diff is in meals, because we don't want to be checking, we don't want to be basically operating with this if diff is not in meals, because then, of course, we will get a key error. Thanks for that, LeetCode. Okay, so that's how you solve that one. Let's go through it one more time. This is our num meals. We set it to 0 at the beginning, and then at the end, we're going to return that modulo 10 to the 9 plus 7. Create our meals dictionary, okay? We basically figure out how many how many times each particular number appears in our deliciousness list. We iterate through the dictionary now, through the keys in the dictionary, and then we also iterate through all the potential powers of 2 that we can come to, right? And we do that by basically saying range 22, because of course we could have a situation where we have 2 to the 20 plus 2 to the 20 is equal to 2 to the 21. And to have 21 as a value, we need to do range 22. Then what we do is we figure out the difference of whatever that particular power of 2 is minus our current value of the key that we're actually on right now in the iteration. We check whether or not the difference is equal to I, and if it is, then we just figure out what's the number of combinations of the amount of times that I appears in our deliciousness list. And then we increment our num meals by whatever that is. Now, if diff is greater than or equal to I, and the reason why we check that is, of course, is to filter out doubles, right? Because we don't want to be double counting it for, you know, sort of the same situation but flipped, right? Where our difference is less than I. And diff is in meals, right? Diff is actually present in this dictionary that we populated up here. Then we can just add the product of the amount of times that I is in our dictionary and the amount of times that diff is in our dictionary. And that's our solution, okay? So that was day 96. If you guys enjoyed that, please like, subscribe. We'll be back some Monday, actually, with day 97. Take care.